Ever wondered why a single weapon can destroy an entire city in seconds, while conventional bombs can only damage a few buildings at a time? Today on Knowledge Hub, we're diving into one of the most powerful and terrifying technologies ever created: nuclear weapons. What makes them fundamentally different from every other weapon on Earth? It starts with where the energy comes from. Conventional explosives rely on chemical reactions, like the rapid oxidation, TNT, to release energy stored in molecular bonds. But nuclear weapons operate at the atomic level, harnessing the forces that bind the nucleus of an atom together. The two primary mechanisms behind nuclear weapons are nuclear fission and nuclear fusion. In a fission bomb, heavy atoms such as uranium-235 or plutonium-239 are split into smaller nuclei when struck by a neutron. This split releases an enormous amount of energy, along with additional neutrons, triggering a massive chain reaction. This leads to an exponential release of energy in a fraction of a second, resulting in a devastating explosion. To achieve this, the weapon must reach a supercritical mass using precisely timed conventional explosives in an implosion design. This is an incredibly complex engineering challenge involving neutron reflectors and precise detonation timing measured in microseconds. But thermonuclear weapons, or hydrogen bombs, go even further by using fusion, the same process that powers the sun. Here, light nuclei combine under extreme temperature to form helium, releasing even more energy than fission alone. These weapons use a two-stage design, where a primary fission explosion generates the pressure required to trigger fusion in a secondary stage. What makes nuclear weapons uniquely dangerous is the multiple layers of destruction they produce simultaneously. First, the blast wave, a massive pressure front that travels faster than sound, strong enough to collapse reinforced concrete structures. Then comes the thermal radiation, an intense flash of heat reaching temperatures hotter than the surface of the sun. This ignites materials instantly, creating large-scale firestorms that consume oxygen and spread uncontrollably through urban environments. But unlike conventional weapons, nuclear detonations also release ionizing radiation, which penetrates deep into the human body. This damages DNA at the molecular level, leading to acute radiation syndrome and significantly increased cancer risks over time. Then there is radioactive fallout, contaminated dust lifted high into the atmosphere that can travel thousands of kilometers. This fallout settles back to Earth, contaminating ecosystems, water supplies, and agricultural land for decades. The critical difference is energy density. Nuclear weapons tap into the strong nuclear force, millions of times more powerful than chemical bonds. A weapon weighing just a few hundred kilograms can release energy equivalent to hundreds of thousands of tons of TNT. Additionally, a high-altitude nuclear detonation generates an electromagnetic pulse, or EMP, which can cripple electronic systems. This pulse can damage power grids and communication infrastructure over vast areas without destroying a single building physically. This is why they are classified as weapons of mass destruction, with long-lasting environmental, technological, and humanitarian consequences. They have reshaped global strategy through nuclear deterrence and the doctrine of mutually assured destruction, or MAD. While representing an advanced scientific achievement, they stand as a reminder of how dangerous our technology has become. So the next time you heard about a nuclear weapon been tested, remember, the same forces that power the stars can also be used to destroy entire civilizations in seconds. If you have enjoyed understanding how nuclear weapons work and why they are unlike anything else ever created, make sure you subscribe to Knowledge Hub for more deep dives into the technologies shaping our world. And as always, stay curious.